Hello guys, in this video, we will build a machine learning system which predicts whether a person has heart disease or not. Let's discuss the workflow of the project. First, we will get the heart data. This dataset contains several heart parameters which correspond to a person's healthiness of the heart. So first, we need this heart dataset. So once we have this hard data set, we need to process the data set. We cannot feed this raw data into our machine learning algorithm. So we need to process this data set to make it fit and compatible for our machine learning algorithm to learn. Once we process the data, we need to split data into training and testing data. This is because we often train our machine learning algorithm with training data and we will evaluate our model using the test data. This part is called train test split, where we split our original dataset into training data and test data. So once we do that, we will feed our training data to our machine learning model. In this case, we are going to use a logistic regression model. This is a use case this use case is a binary classification. So here we are going to classify whether a person has a heart disease or not. So this is a binary classification, that is either yes or no. In binary classification, logistic regression is very useful method. So for binary classification, we generally use logistic regression method. So finally, after training, we feed new data to our trained logistic regression model. We feed new data to our model so that it can predict whether the person has heart disease or not. Now let's get into the coding part. So we will do our coding in Google Collaboratory. So I have just uploaded the dataset. So you can see the hard dataset here. So I will provide this hard dataset link in my description box. So let's start by importing the dependency. So these dependency are or libraries or the functions which we will be needing in our machine learning project. So let's start. Import numpy as np, import pandas as pd, then from sklearn dot model selection, import train, test and split. So then we will import like from sklearn. We'll import our linear model. So import logistic regression, and finally we will import the evaluation matrix. Import accuracy score. So these are all the dependency we will import. So numpy and numpy as np is a it will create numpy arrays like list in Python, and pandas as pd, it is useful for creating data frame or you can say structured table. And we will import the machine learning model that is we are using here is logistic regression and the evaluation matrix. So let's start by loading the CSV data to pandas data frame. So heart data equal to pd dot read CSV. So click on this folder link and just click on these three dots and copy the path and paste it here. Just enter shift plus enter. So our data set is loaded in pandas data frame. So now let's print first 5 rows of the data set. That we will do by using the head function. So okay, it should be HEART. So you can see the first 5 rows of the data set, and let's also print the last 5 rows of the data set. So for that we will use the tail function. So these are the last 5 data set. So you can see there are 14 columns like age, sex, CP, and trace BPS, and these are the columns, and this is our target column, which is our label column, and these are the features column. So basically totally we have 14 column like age, sex, and chest pain type. CP is like chest pain type, and resting BP, and blood sugar level, and etc. So you can see that there are we also have that ST depression and the ST segment in the ECG. It's a ECG curve image. So there will be these kind of waves. So this represents a functioning of a person's heart, and this is how typically wave look like for a healthy person. If there is a change, that means the person heart is not performing well. ST represents some abnormality in ECG curve. You can see. So you can see that there is an exercise induced angina. Angina means it's a pain in heart which is caused due to low blood in heart when a person is exercising. So these are the medical parameter we will be having. The last column is the target column, and it contains the value as 1 or 0. 0 it represents the person is healthy, and 1 represents a person has heart disease. So let's proceed. So now let's see the number of rows and columns in the dataset. And that we will do by using shape. So there are 303 rows and 14 columns. So 13 are our feature column, and 14th one, that is our target column. So now we will get some more data and information about our data set, and that we will do using the info function. So you can see these all functions have the data types, all the columns data type. So you can see old peak is having a float data type. So now let's check for the missing values. Is there any missing values in our data set or not? So that we will do by using is null dot sum. So you can see that our data set is perfectly fine. That is, there are no missing values in our data set. So we don't have to do any sort of imputation or anything, or dropping rows. So now let's proceed with the with statistical measures. So that we will do using the describe function. So you can see the count, mean, standard deviation, minimum 25 percentile, 50 percentile, 75 percentile, and the maximum value of each column. So now let's check for the distribution of the target variable. So hard data target dot value counts. So you can see there are like one that is the defective heart are like 165 and the healthy heart are like 138. So it's quite like evenly distributed. So it's close to evenly distributed. So we can take it. There is no particular bias in our data set. So let's proceed with the splitting the features and target. Hard data dot drop columns equal to this target axis equal to 1, y equal to hard data so we have let's print now. Let's check the value of x and y. So for that we have to print the value of x and y. So you can see the value of x. Now let's print the value of y, which is our target column. You can see there are 303. So now let's proceed with the splitting the data into training and test data. So we'll proceed with that. So we will use x train comma x test y train y test equal to train test split. Then we'll pass the value of x, y, and the test size equal to, let's say 0.2, and stratify equal to y, and random state equal to 2. So stratify equal to y is basically splitting the data equally. Like you can see that there are the healthy person is a 128 and the person having heart disease is 165. So it will be by using this stratify, it will be distributed evenly. So our data will not be a biased data. And random state equal to 2, it's used to split data in a specific way. That is, your and my data is split in the same way. It is generally used to reproduce the code. So, and test size is 0.2, means like 20% of the data set will be used for the testing purposes, and 80% of the data set will be used for the training purposes. So let's see. We will first check the shape of like our training data. So print x dot shape x train dot shape and our test data also x test dot shape. So you can see that our training original training data have 303 and 13 feature column, and that is divided as a training set and testing set. For training purposes, we are using 242 data set, 242 rows of data set, and for testing, and there are 61. So now we will proceed to our model training. So model equal to logistic regression. So we will train our model. So model dot fit x train comma y train. So you can ignore this warning sign. So now our model has been trained. So now we will check the accuracy on the training data. So x train underscore prediction equal to model dot predict x train and training data accuracy is equal to accuracy underscore score x train underscore prediction and y train. So we'll run this. So now we'll print the accuracy on the training data. So print accuracy on training data training data accuracy. We'll run this. So our accuracy is coming out to be our accuracy is coming out to be 85%, which is quite good for a training data. And now let's test our accuracy on the test data. So we will just copy and replace the all training data to test data. We'll replace it as x test. So here also test. This is our test data accuracy. X test prediction and y test. So now we will print the accuracy. So accuracy on test data. test data accuracy, run it. So our accuracy is coming out to be 81%. So which is quite good, and we can see that our model is performing good. So now we will proceed in building a predictive system. So for that, we'll take input, score data. So here we have to go. So here is a hard data set. So we will open that data set in a notepad, and randomly we will choose any one row, means to check whether it's working properly or not. So let's pick randomly this row. So it's showing that the person has heart disease. So we'll copy this and paste it here and remove the label column. So now we'll change the input to the NumPy array. NumPy array. So np dot as array will pass our input data. So as the prediction is only done for one instances, so we have to reshape the NumPy array as we are predicting only for the one instances. So for that we have to reshape input data reshaped equal to input data as np array dot reshape 1 comma -1. This is that reshape is 1 comma -1. This is as we are taking only for one instances. So we have to write in that way. So then we'll do the prediction. Prediction equal to model dot predict our input and input data, that which is reshaped data, will print the prediction. So we'll again use a if statement. So to identify that the person is having a heart disease or not. So if prediction of 0 is equal to 0, then print the person does not have a heart disease. Else print the person has heart disease. So we'll run this. So you can see we are getting one, that is the person has heart disease, and you can see that this label column also has indicates that the person has heart disease. So you can see that our model is working fine, and yeah, that's it from my side. Hope you enjoyed this video. Thank you.